told you at the top. Agriculture and
What? All right. So last time we did this. This is up on Canvas, not with all my writing on it, obviously. This is an excellent. Oh, by the way, let me talk about a couple things. One thing, I always forget this, and I don't mean this to be confusing, but this book actually uses my preferred thing for the alternate hypothesis. So it's almost kind of good that apparently most of you haven't started the homework. So I can make this point right now. This book uses something that makes more sense. Instead of H1, what would you call the alternate hypothesis? H what? For the alternate hypothesis. Alternate. Huh. So we're talking about the hose and the ha's instead of the hose and the highs. Okay. So different books I've used over time use either one of those two things, to be honest. It really doesn't matter what symbol we use, as long as we understand it means the alternate hypothesis. And HA actually makes more sense. HA, alternate hypothesis. Okay, maybe. Now, looking at this sheet, does this look at all familiar about the coyotes and Phil? Well, why did I do it this way? That was kind of dumb. Sorry. Anybody? Does this?
I think we did finish it. Mine is completely done.
Yeah, I think so too. Because so is mine. Not highlight, Jeff. So this is HA. The book uses HA. So in case you see HA, now you know what it means. Yeah, we made it all the way to the end, and this is where some of you guys were so excited that a teacher told you to plagiarize, but it was a very specific, very small portion. Okay, so don't get me in trouble with my English colleagues. All right, so if you were not here last class, that was a rough one to miss because we went through all the steps of a hypothesis test together. Okay, so I want to focus on a couple things. We did talk about the p-value. So I want to focus on that first. Talk about what the p-value is. Then I want to do a couple more examples of hypothesis tests, and then we'll talk about a couple other things. Okay, so let me stop sharing here. I'm going to stop sharing. Stop! All right. Oh, let me make it all about me too. Hello. Okay. If there's no questions, we're going to jump right into example. Go ahead.
Can you go over the p-value again? I don't really remember what that was.
Exactly, beautiful. All right, so I want to focus on p-value. Let's look at this one more time before we do this. So here are the steps. This is an awesome. Sorry.
Before you get, what's a Z star? I didn't really get that either last class.
That's perfect because those two go together. All right, here we go. This sheet again is up on Canvas. It's I think it's called Hypothesis Steps. Explain, maybe. Print this bad boy out, have it sitting next to you as you do. Now, another thing about the book. Section 9.5 is where the full hypothesis problems are. Section 9.1, 9.2, 9.3, 9.4 focus on parts of the hypothesis test because there's 5 parts to it. Right? You guys kind of with me? So section 9.5 is the first place you will see a complete hypothesis test using all the steps on this sheet. 9.1, 9.2, 9.3, 9.4, they talk about different parts and aspects of the tests. They're not full tests. Is everybody with me so far? So if you wanted to, you could jump into 9.5 and try a complete test out, or you can kind of build up. It's up to you. Now, so like we discussed last time, the 5 steps are basically, what the hell are we talking about? Right, write the claim down. What the hell can we use to talk about it? Z or T. where the hell is evidence? Where does evidence start, right? What does it take to show evidence? That's part C. I really want this to make sense. So it kind of makes sense. If I'm going to go test something, I have to know ahead of time what it will mean if I see this, what it will mean if I see that. Does that make sense? How can I test something without having an idea ahead of time of how to interpret what I find? So this sets up where evidence starts, right? And again, this is directly tied to our definition of unusual. It's just that in different situations, we want to redefine what unusual is, not just 2 steps away, but sometimes it'll be, in this case, 2.326 steps away. That's where unusual would start. Is everybody with me so far? Does this bring back memories? Are you guys completely bored? All of those could be true at the same time. All right. Then it kind of makes sense. The minute we set up where evidence will be, we see where we got. Did we make it into where evidence would be? Did we find enough evidence? So we calculate. Now here's what Z star is. Why do I call it Z star? Well, it's a Z score, right? It's a Z score we calculate from our sample. Is everybody with me? We've done that before. So why does Weird Ass Jeff call it Z star? Because isn't there another Z score right here? Isn't that a Z score? Yes? That right there, that's a Z score? Okay. And this one is what the book calls the critical Z score. And it calls this the critical region, which is so stupid.
So the Z star is marking where the
sample
is.
Okay. And I like that visual too. You can put a little star. Look, there it is. It's planting its little flag way out there in rejection land. I guess we could call this friend zone. No, let's just stick with rejection region. All right.
Oh, so it's for the rejection region.
Yes. So This is the rejection region. And the Z star, I could just kind of visually identify, did it make it in there or did it not make it in there? And all right. So there's a couple things happening at once here. We're talking about specifics and we're talking about concepts. And it's always a hard thing to talk about both at once. So let me do this. Let's focus on Z star. All Z star is the Z score we calculate. I call it Z star just to differentiate it from this Z score. This Z score tells me where unusual starts for this problem, where my sample has to get to show evidence that the null is wrong. So you always have 2 Z scores. You have one that says your sample has to get at least this far, and then you have the one I call Z star, which is how far did my sample get? Makes sense, right?
Sort of.
So I always like the analogy of if you're a football coach and your entire football team is slow as shit, right? Slow as molasses in January, right? You with me, everybody? You're all football coaches. All of your teams suck in terms of speed. So you go out and you say, I want to find somebody who's fast. So you would set a benchmark, right? If you have new people that want to join your team, wouldn't you have them race? Wouldn't you have them run a certain amount of distance? Wouldn't you have a benchmark set? If you can run this far in faster than 6 seconds, then I'll consider you for the team. Or is everybody kind of with me? Does that make sense? So you've set up a benchmark ahead of time that will be evidence that somebody should get on your team. That's what this is. This is the benchmark right here. This is the benchmark. This is the person that goes and runs. Did they beat the benchmark? In this problem, they did. They made it past the benchmark. They made it further away. Okay, let me stop for a minute. Does that analogy make any sense at all?
That helped a lot.
All right, so that's the concept of what we're doing. And it also neatly ties in with the details of what we're doing, right? set a benchmark, and then go see if this one got past the benchmark. So that's why in this case, we succeeded. Now, why does that make sense? This whole thing about, well, if the sample gets here, that means the null is wrong. Why does that make sense? Okay. And then we'll talk more about p-values. So let's do this. Let me talk about why. Okay. I love you guys. Okay. So what is true about the null hypothesis? And let's put up here. What's true about the null hypothesis? What's always got to be true about the null hypothesis? Anybody? There's one thing that's always true about the null hypothesis.
It's in the chat.
Oh, I'm sorry. Corbin's always the chat assassin. I'll never see him coming. All right. So there must be some kind of equal sign. Equal to, less than or equal to, greater than equal to, right? It's got to be one of these three things. And then the HA is going to be greater than, not equal to, or less than. Correct? Everybody with me? Okay, I like it. So, on this picture, where does the null hypothesis believe things are? It believes things are here somewhere. So either it's this or below, or this or above, or it's this and here somewhere. So it thinks it's in here somewhere. That's where things will be fine. And we know this makes sense. If I take a sample from a population, where should the sample mean be? Where would we put money on the sample mean being? Does that make sense what I just said? Is this out of focus? There we go. Would you put money on the sample mean showing up there?
No.
Hell no, of course you wouldn't, because you're not crazy. Some of you guys would be like, what's the rate of return on that? Be quiet, gamblers. All right. Wouldn't we expect it to be somewhere close to the mean? That word close is very important, right? It's a very easy word to go past, but close is important. What is close? Now it makes sense, right? If I take a sample, I expect the sample mean to be close to the population mean. We know that. We've known that since day one, correct? It should be very, very unlikely for a sample to have a mean very far away from the population mean. If the average age is 38 somewhere and I take a sample and I get an average sample mean of 2 years old, something has gone wrong. Is that impossible? No. But it's like rolling a die and getting a 6 80 times in a row. You're like, there might be something wrong with this die, right? Is it impossible? No. Is it insanely improbable? Yes. All right, sorry. Stay with it. So this is basically, all right. That's where the hoe will be happy. That is where the null hypothesis expects things to fall. If we get something, so we set up something, what is far enough away? It could even be a two-tailed test or a one-tailed test. This is where unusual starts. So if we get a sample that's like right here, did we just do something that would be highly unlikely if this is where the mean is? Do you guys agree that that would be really unlikely to get this sample way up here if the mean really is right there? Okay, I got two people nodding yes, and everybody else is not showing me anything. Let me try this again. Let me just tell it to you. Shit, yeah. This would be incredibly unlikely to do if the mean is actually there. So what's more likely? That we just accomplished something really improbable, or that the mean is in the wrong place? What's more likely is, what's more likely is the mean is in the wrong place. Is there a chance we're wrong? Always, because it's life. That's why I love statistics. Right? Statistics is like, that's nice math. Let's talk about real life where shit isn't perfect, right? All right, sorry. So we set up the rejection region, which really is just saying, for this problem, where would a sample have to show up to be so unusual that it's evidence that this is not really where the middle is? The middle in this case is actually higher than. Maybe the picture is more like this, where the mean is higher. Does that make any sense? So so if I got a sample right here, what would that mean? If my sample was right there, it's my sample mean. Would that be evidence that the null is wrong? Is it far enough away to show evidence that the null is wrong?
No.
No. Does it mean the null is right?
Also no.
Also no. I love it. Perfect. So that is why you can either reject the null or fail to reject the null. We say that very specifically. Okay. So at the end of a court trial, for example, what are the two possible outcomes, ignoring mistrial or any of that? If there's an actual outcome, what could it be?
Guilty or not guilty?
Does anybody say innocent?
No.
No, we just say not guilty, meaning we haven't found evidence yet that you're guilty. Are you guys with me out there? So
can you do it with a number next? I'm having a hard time understanding this still.
which part?
The star part, the Z star part.
Oh, all right. All right, so somebody help me out. Let's just focus on one little piece of hypothesis test. Let's say that my alpha is 0.05 and it's a one-tailed test and I'm using z-scores. And I'll say the tail is here. Can somebody tell me what that z-score is? What would you use to look it up?
The T-score chart.
Yes, cool. I like it. So let's say, for this example, let's say that the null, say the alternate says it's less than 5, so the null thinks it's at least 5. So in this case, the null believes it should show up in here. So if we show up here, that's evidence against the null. So does somebody have that z-score yet?
1.645.
Yeah, and one little thing about that's not quite right.
It's negative.
Good, negative. So be really careful. Notice there's no negatives on the t-score chart, correct? The t-score chart has no negatives. Why? Does that mean there's no negative t-score? Of course not. It means that we're the humans. We have to know when it's supposed to be negative or positive. If it's below the mean, it's got to be negative, right? Well, z-score is what we're talking about, but then whatever. Same thing. All right, now, if we calculate a z star, let's say that we get a z star of negative 1.62. Did we make it into the rejection region? Real quick, before you answer that question, why do we call it the rejection region?
Because it's such an outlier that it's going to mess with the data.
No, be careful. It's not going to mess with any data. It is data. It's not going to mess with data. But what is it going to reject the idea of?
The sample mean being there?
No. All right. If we do get a sample mean in here, what would that be evidence against? Let me try this way. If the mean really is 5, where should a sample mean show up? Close to 5, correct?
It's okay. It's that the sample mean is wrong, right?
No.
Oh, that hurts.
It does a little bit. A sample mean cannot be wrong if we have a nice random sample, correct? I mean, does that make sense? So a sample mean can't be wrong. Who thinks it should show up in here? The ho or the ha? Who thinks it should show up in here?
The hoe.
The ho, thank you. Right, it's just a strange phrase to hear any teacher say. The ho, thank you. So if I did get a sample show up in here, what would I reject? I would reject the one who thinks it's supposed to be here. That's why we call it the rejection region, because if I get a sample that shows up here, that is so far away from where it should have been if this is the real mean, that this probably is not the real mean. I can reject this person. I really want this to make sense. The one who thinks the mean could equal 5 must be wrong if we get a sample that's so far away from 5. How far away? This far away, because that's what the problem set up where unusual starts. Maybe. It really is as simple as, if this is the real mean, any sample I take should show up in here. It should be very unusual for a sample to show up down here. How unusual? 5% chance. So if something does show up down here, that is evidence against the mean being 5. That means I can reject this guy. I can support this guy. Now, somebody else could do the same kind of study and end up getting an opposite result. And then we have to and that's the whole idea of science not being accepted until a result is replicated. Have you guys heard of that too? If one person in one backstream lab somewhere does something, it's not going to mean shit until another group accomplishes the same thing. Replication. Have you guys ever heard of that? No? You're all like, I don't know what you're talking about anymore, dude. I'm already tired and class just started. What do you want from me, man? All right. Now, in this case, if we have a sample and the Z I calculate from the sample is negative 1.62, did we make it into the rejection region?
No.
Yeah.
Oh, I got a no and yes at the same time. It's like antimatter. What does it take to get in here? Don't I have to be below this? So is negative 162 more negative than negative 1645?
No.
No, I made it like right here. So did I make it far enough away? Did I get out of this guy's territory? Did I make it far? No, I'm in his clutches. I failed to reject what he's saying then. I have not shown evidence that this is wrong. I got pretty far away, but not far enough away to be evidence. At least not at this level of significance. Now, how are we doing so far? Is it still foggy but better? Is that a good way to interpret what's happening? Still foggy but better.
So then we would say that the sample fails to reject the null.
Yeah, we would say we have not found sufficient evidence to reject the null hypothesis. If that was the claim, that's how we would say it. Yeah, we have not found sufficient evidence to reject the claim that the mean is at least 5.
Okay.
Now, p-value. Now watch this. Where's alpha on the picture? Where's alpha in my picture? Don't say there. I mean in the graph. Where's alpha in the graph?
The middle?
No.
The shaded area?
Shaded area. Alpha is the area in the tail or tails. This is a one-tail test, so it would be right there. Is everybody with me? That area is alpha. So that is the area that is in the tail that the critical z-score makes. Let me say that again. Jeff's gone crazy. That is the area in the tail that the critical z-score makes. In fact, isn't that how we freaking found the z-score? Is by looking that area up? Yes? Yes. Okay. What's it got to do with anything, Jeff? All the p-value is the area in the tail that our z-score makes. Can you find the area that 1.62? Negative 1.62. Can you find this area? That's the p-value. That's all it is. It's exactly like alpha. Alpha is the area in the rejection region. The p-value is the area in the tail that our z-score makes. Ouch. Could you find the area? This is chapter 6 now. Find the area in the tail that this z-score makes. What does that mean, Jeff? Look this up in the z-score chart and you're done.
0.0526.
It sounds about right. So another way to interpret this, instead of comparing z-scores, I could compare these two things. This is the maximum probability we'll accept to reject this. Did we get below this? No. So another way to tell the answer to a hypothesis test is my p-value less than my alpha? No, it isn't. We fail to reject. Damn. Because, now watch, I really want this to make sense. If my rejection region tail is bigger than my p-value tail, I really want you to get this. Doesn't it just make sense that so here's my z star. If my rejection area tail, that's alpha, if that is bigger than my p-value tail, didn't my sample get into the rejection region? So let me write this the other way. If p is less than alpha, reject H naught. If p is at least alpha, fail to reject the null. So it's not, it can never come to a different conclusion. This is easy, right? You guys with me? Comparing the z-score to that z-score, I can already I can already tell I failed. But I can compare a p-value to this, and I can also tell that I failed. All right.
I have a question.
Sure.
So are you saying that the p-value equals the z-star?
The p-value equals the area in the tail that the star makes, that the z-star makes.
Oh, okay.
So the same way that alpha is an area, right? Alpha is an area that leads me to the z-score. My z-star leads me to a p-value area. They're analogous. So p-value is like alpha. They're both areas in tails. Z-star is like this. They're both z's, right? Some weird shit, Jeff. I know. All right. The fundamental idea that all of this captures is if my sample is so far away from where the middle's supposed to be, that's evidence that the middle isn't where it's supposed to be. That's it. That's it. That's what all this boils down to. So, the power of my mind. What will we see in journal articles? Unfortunately, I've had a rough time. I should just break down and show you freaking COVID bullshit because I can't find much of anything. I found one little thing here. Oh, look at this beautiful thing. This is so freaky. Association of sleep duration in middle and old age with incidence of dementia. Yeah, okay, I'm sorry. You'll see some 95% confidence interval business. You guys with me? We're not going to analyze this. I'm sorry. What's the hazard ratio? I don't care at the moment. But there's the confidence interval stuff. If you scroll down a bit, there's some results. There's some standard deviation kind of stuff. Neat. There's some range stuff. Neat. And then we finally get to, where'd it go, Jeff? There we go. Look at this shit. Look at this. Look. Sorry. Let's read through this. The lowest dementia incidence was observed among those who slept 7 hours a night. An analysis adjusted for socio-demographic factors, short sleep duration was associated with a higher risk of incident dementia. Now, there's some highfalutin words in there, but it's not too hard to understand. They're saying that they found evidence that the longer you sleep, the less chance of dementia, correct? How strong is their evidence? Right there. They captured it very quickly. Is this a small p-value? They're saying that all their p-values from what they just said are less than 0.02. Is that small? What do you think? It's fine. If you're having trouble answering it, are you saying to yourself, well, what is small, Jeff? What is small? Is anybody wondering about that? Yes, that's not a bad thing. What was it in this problem? Wasn't small enough 5%? So anything less than that would have been evidence. In fact, that's the standard that we use is 0.05. That's the normal thing. All right, now stay with me. Stay with me. If you are in this field, all right, whatever the situation we're talking about, doesn't each person have their own level of evidence they'll accept? Does that make sense? Won't some people just buy whatever you say? Do you know these people? They'll just go, wow, and then later like, you were lying. Like, of course I was.
The headline people.
Huh?
People that believe the headline.
Yeah, they just stop at the headline. They just believe it, whatever the hell it is. There's too many of those. So their alpha is high. Maybe it's 0.2 instead of 0.05. They're not very skeptical. Are you with me? Whereas some people are going to have an alpha 0.01, 0.005. So this is going to be good for most people. Most statisticians would say that's pretty good evidence. But maybe there are some statisticians who actually are some medical professionals who would say that's not good enough for me. I need some more details. That's still too high of a doubt. There's a 2% chance that these are not actually correlated. Does that make sense what I just said? Roughly, that it doesn't exactly mean that, so don't get me wrong here. People misinterpret the p-value all the time, but it is a basic way to measure how significant your results are, which is why alpha is called the level of significance. And I'm highlighting shit on the screen, and you can't even see it anymore. I'm sorry. So this is pretty significant for most people. Although some would say, no, I'd be more impressed if it was less than 0.01. So good try. It's like, dude, calm down. I have no idea if you guys are with me or not. So what I'm really trying to say is in the real freaking world, and you're like, stats is not in my world. Be quiet. In the real world of people that use statistics, alpha does not exist. Alpha does not exist. And at the same time, it does. It's everybody has their own alpha. It's how much evidence you need before you're convinced of something. So that's why in journal articles, you will only ever see them report p-values, because then everybody reading it can make up their own mind. Yes? Does that make any sense? The p-value is a level of evidence. It's how much evidence that their analysis found. And then you can compare that and say, is that enough evidence? So the smaller the p-value is, that's the more evidence that the null hypothesis is wrong. That's what the p-value fundamentally points to. Whew, oh boy. And how do you find the p-value? You look up the z-score, the z-star. You look it up. Let's do another example of finding the p-value for a two-tailed test. Oh, wait a minute. I have an example. Let me see. Oh, give me a minute. What is this example I have put up here? Ask Jeff, what have you been doing? Let me see. Since my baby left me. Let's see. Oh, perfect. Okay. We're going to do this example. All right. Look at Past Jeff, go. All right, guys. So go to, oh shit, I got to make this active. Hold on. Publish. Okay. If you go to Canvas right now. What was that? All right. I have no idea what my computer said. If you go to Canvas right now. Shisa Misa, what did I just do? Did I just do something? I hope not. I don't know what I just did. No, okay, good. Oops, I just unpublished that. Okay, there you go. Glad I caught that. Student view. If you scroll down, go to Canvas, scroll down to unit 9. You go to hypothesis test practice 1. That's me promising there are more. Let's do this first side here together. And then I'll let you guys do the other side. So I'm going to stop sharing this way. I'm going to share it a better way. Is everybody able to go get that? You guys all with me? Okay, I'll take that as yes. All right, let me find this. Strangers in the night. Let's see, where are you? Dadgummit, Jeff. Hypothesis, practice. Donde está? Dadgummit. All right, I'll just download it again. Who cares? Come here. All right, download. All right. Okay, this process is so fast. Okay, come on. No, I don't want to open it up that way. Go away. That's crap. All right. Here we go. Perfect. Doobie doobie doo. All right, guys, here we go. Let's try this one. Everybody get ready. Here we go. Read through this about the Ford Focus. Do they still make those things? All right, everybody should be working on this. So, somebody help me out. What's the claim that's being made?
The mean assembly time is 37.3 hours.
No. It's not a claim. That's something we found in a sample, right? I don't have to claim anything about that because I can just see the sample time is 37.3. Why did we go to this Ford plant? Well, we were going there to test. Why did we go?
To see if their assembly line time is the same as the overall average.
So what's the claim that we're checking out?
It takes 38 hours to assemble a Ford Focus.
The mean is 38. So I really want you guys, does this make sense? Across all Ford plants, the mean assembly time is 38 hours. So of course we're going to do quality assurance, or we're going to do, what do you call it? Performance tests. We're going to go see how far off from that 38 hours is a plant. Or if they're too high, we'll ask them to share. No, if they're too high, then we'll say, okay, what's wrong? What's going on? Why can't you be closer to? And if they're lower than 38, we'll go, whoa, what are you guys doing? Is the quality still good? Are you guys cutting corners? Is everybody kind of with me as far as the real world reason we would do this? Okay. So the very first thing you care about, the only thing you care about at first is the claim. Now, where will the claim go? Is it going to be in the HO, or let me call these the HAs now? Just to be the same as the book. Is it the ho or the ha?
I'll go on the hoe.
What'd you call me? Oh, yeah, you're right. The I'm sorry. I set you up for that. Why is it in the null hypothesis? Why is it the ho?
Equal sign.
Yeah, it's got a freaking equal sign. So does everybody understand what I just did? You write the claim down. It could be anything. If it has an equal sign, put it next to the HO. If it doesn't, put it next to the HA. It's just how we built hypothesis tests. Does anyone have a clue what the HA is going to be now?
Mean not equal to 38?
Good. It's got to be the opposite of the ho. So the ha is not equal to. So this is finally an example of how many tail test will this be?
Two, because it can either be more or less.
I really want everybody to understand it. In fact, the symbol we used to use, instead of saying this, we used to say this. Or I can't remember now. It's been so, I think it was the second one. But math people do not like multiple symbols in a row when it's unnecessary. But does everybody see that actually makes more sense in a way? What is it? How can you be not equal to something? Can't you be higher than it? Or lower than, it's a two-tailed test. Either way will show evidence. How do I show evidence is not equal to 38? Either higher than 38 or lower than 38. So I have two rejection regions in a way. All right. So are we going to use z-scores, t-scores, or nothing? What two things do you have to check? What's the most important thing? Go ahead.
Would you use z-scores?
Why?
Because the n is greater than 30 and we know the population standard deviation.
Perfect. Those are the two things to check. One, is it normally distributed? If it doesn't say it is, the sample's got to save our ass, right? And then chicken, lettuce, tomato, or central limit theorem says all good. So I can't do shit if it's not normal. So nothing is now off the table. Then I look to see which standard deviation do I know, right? If it was the sample standard deviation and I didn't know the population one, I would have to use a t-score. Let me mute my email. There we go. So we totally can use z-scores. Dudular. All right, now please let me know if anything's not making sense. And you're like, it would be easier if I would let you know if something made sense. Okay. Define the rejection region using alpha equal to 0.05. So how many tail test?
2.
2. It's a 2-tail test. Alpha is 0.05. So now you know where to look on your T-score chart. Thankfully, no one's yelled at me. We can use Z-scores. So why are we going to look at the T-score chart? Because Z-scores are on the T-score chart at the bottom. So when I say define the rejection region, I mean draw the picture. Does anyone have the Z-score yet? The two
Is
Z.
it 1.960?
Yes. And so there's negative 1.96 and 1.96. Right, so that feels a lot like a confidence interval, right? In a sense, because of course those are two-tail things. So it kind of makes sense. This is a two-tail hypothesis test. So take a minute and see if you can't put into words the meaning behind this picture. All right, so tell me, what the hell does this mean? If Z star is what, then we can do what?
Can you say if Z star is greater than negative 1.96 and 1.96, then
No. Stop. If it was greater than negative 196, it won't be here, will it?
no.
Can't say this. You have to say this in two separate things. So if Z star is greater than 1.96 or less than negative 1.96, correct? How do you get in here? You have to be less than negative 1.9. How do you get in here? You have to be greater than positive 1.96.
Oh yeah, sorry. That's
Okay.
yeah, you're right. I get it now. Then we can reject HO and support HI.
Yeah, since I used HI, you could also use HA. That's what the book uses, HA. That's what I actually would rather use. I just always forget that this book actually uses it. So we can reject the null, support the alternate. And by the way, I didn't just say two different things. I said one thing. If I reject the null, that automatically means I'm supporting the alternate because they're opposite takes, right? So this is where the null thinks it's supposed to be. So if I show up here or down there, that is evidence that this guy is wrong. That's the bottom line. That's what this whole thing is all about. All right. Take a minute and see if you can figure out what the Z star is. Let me kind of get everything down here. Let's see. Blah, 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 blah. Yeah. Oops, sigma. Everybody with me? So I just got this from the write-up. Of course have to do this. I always have to do this. Always, 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 because I took a sample. I'm talking about sample means. So does somebody know what that is? What's the new standard deviation?
0.267.
And what goes on top here? What's our data? What's the data we found? What's our data?
37.3.
Yeah, so it's always our data minus the supposed middle. So the number from the claim, 38. I want to see how far away did our sample get from the supposed middle. What's that, Shannon and Jeff? I don't know what that's going to be, Jeff. It's going to be 2.7. I don't know. Do it. You got a calculator in your hand. Oh yeah. Oh, so negative 2.62. I was close. Is that what you guys got? Negative 2.62?
Yeah.
All right, let me shut up here for a minute. That's interesting. What's the square root of 0.7? Holy shit. Wait a minute. Oh, I'm not. All right. Now, here's where things get weird, kids. Not just with what I just said. That was kind of creepy. Things are getting weird now, kids. Remind me, in this picture, where is alpha?
Shaded area.
And aren't there like two of them? And there's 0.025 in that one, right? So if I said alpha equaled 0.025, that's obviously wrong, correct? If I want to know what alpha is and I just know that this is I got to double this, don't I? So the p-value has to work the same way. The p-value, since it's a two-tailed test, you find the area in that and then you double it. So what's the area in this tail that our z-score makes? I don't know. I don't have my z-score chart. Oh, man. Let's see. He's boring himself. Yeah, you know, be quiet. Let's see. Anybody?
I got
Negative
0.0044.
0044? Does that sound about right? Everybody? I'm going to crowdsource this. So then what's the actual p-value then? I know I didn't ask for it, but let me just add it in. There, now I did. Ha ha ha. So the actual p-value then will be 0.0088. Holy crap, Jeff. For a two-tailed test, you double the area you get because that mimics what happened to alpha. So we can tell the answer to this test by looking at our z-score. Did we make it far enough away to find evidence?
Yes.
Yeah, we did. We're way the flipping hell down there. I almost said fudge. So down here is where we are. So that is obviously evidence against the one who thinks it's supposed to be here. Yes? So that means that we have succeeded. That means that I can reject the null, support the ha. Ha 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 ha. All right, let me stop for a minute. There's a lot going on here. At the same time, there's very little. So this is important. That tells me where my sample ended up. Remember, that's what a z-score does, is it tells me where I am. My sample ended up very far below where it should have been, if this was the correct mean. Therefore, it's more likely that that was not the correct mean. It's more likely that this is wrong. It looks like the mean is not 38. It's actually less. Does that mean that this, what does that mean about this Ford plant? How are they doing? That's evidence that they're doing that what? Their assembly time, we just showed evidence that their assembly time is not 38. In fact, we showed evidence that their assembly time is less than 38. Are you with me? So are they doing better, worse?
Better. Well, depends. But
Oh yeah, true. So that means that their assembly time is better than average. Then the next thing we want to go is, are you making substandard cars? We better check the quality of your cars. And if they're good, then we want to figure out, damn, how do I replicate what you did at other plants then, right? Does that make sense to anybody? A little bit?
Yeah.
Does Ford ever actually do this? I don't know. I would think they would. I never worked for Ford, thank God. I mean, I don't know if anybody likes Ford. I don't mean to shit on Ford. All right. So what is the conclusion? We basically have the answer here. So does anybody not understand how we got to be able to say this?
I don't.
Okay. What does this region mean? Why the shaded in part? If we make it in there, right? If we make it in there, then what can we do? We can do that. Is that cool?
Yes.
Okay, so that's what we talked about right up here. If we make it into one of these shaded regions, we can reject the guy who thought it should show up in here. We made it into this shaded region. So we can reject the guy who thought it should show up in here. So if he's wrong, then what's that mean about this one? It looks like if this one is wrong, at the same time, it looks like this guy is right, because they hold opposite opinions. If one of them is wrong, the other one's automatically looks to be right. I really want this understood. So it's okay if this is still an answer of no, but you gotta let me know. Is anybody still not understanding how we got this answer here? If the answer is no, it's fine. I just need to know. So again, it's because we made it in the rejection region, we're allowed to reject the null hypothesis. All right, now, believe it or not, students normally get these steps eventually pretty well. They can do this stuff because it's kind of recipe-ish. But E is what kills us. We sort of just guess at words to throw down and kind of have you ever seen those magnets you put on the fridge, the poetry stuff? You just kind of throw a bunch of magnet words and you're like, please let this be the right thing. So here's what the magic is. There's never any ambiguity. Which one was the claim? The ho or the ha? Which one was the claim?
the hoe.
The ho. So I'm not going to use this language. I'm going to use this language. I'm going to talk about the claim. So we have found evidence, sufficient evidence. We have found sufficient evidence to this. Reject the claim that the mean assembly time, holy macaroni, at this plant is 38 hours. Oh my God. That was a lot of writing. Okay. People are always, do I say reject here? Do I say support here? What do I? No, there's never ambiguity. Look at what your little baby conclusion was, and then pick the wording that talks about the claim. Does that make? I'm sure you guys probably feel mostly overwhelmed right now, so I'm going to stop asking if that makes sense. And instead, right after I said you guys are feeling overwhelmed, I'm going to throw you into this. Do this one on your own. Do this one all by yourself. Oh, I'll give you one little clue. Okay. There's a difference here. Where did the standard deviation come from that I tell you? If you read through this.
A sample.
Yes. That's all we'll say. So the standard deviation in this problem, the only one that I know, came from a sample. That means something. All right, go ahead. Do this one. I'm going to stop recording for a little bit. Not record.
It has to have the equal sign.
Yes. The null has to have an equal sign. Does our claim have an equal sign?
No.
Nope. Doesn't have any kind of equal sign. So it's got to go here. Do you guys understand that? So which one, where's the claim go? The ho or the ha? Why is that a crazy question? In general, where's the claim go? You're like, I can't answer that question because it depends on if it has an equal sign or not. Does that make sense? Okay, and why do we do it that way? Because that's the way we chose to set things up. We always want this to be the one that we can show evidence for. So what's going to go next to the ho?
That the M is greater or equal to 906.
Okay, I'll let the M reference go. But yeah, you're right. Okay. So is this going to be a one or a two-tailed test?
One.
Down.
One tail, exactly. Because this guy is less than, it's going to be one tail down there. Right, the tail is always set up by the ha, because that's the one I can show evidence for. Now, it basically gave away part B, but what are the two things we got to look at?
Sample size and whether or not the standard deviation is known.
Yeah, in this case, sample size, because it doesn't say anything about normality, but we have to show it's normal somehow. And normally it's going to be, sample size is going to be big enough, but sometimes they'll just say it's normal, right? And be careful, not the standard deviation is known, but which standard deviation is known, right? Do we know sigma?
No.
Nope, sigma unknown. So we must use t-scores. Jeff? Okay, maybe. So now, what do I need for the rejection region? What's alpha?
0.01.
0.01. It's a one-tail test. T-score, so what else do I have to know so I can look this up? When I look at the T-score chart, how do I know where to stop? What else do I need to know to use the T-score chart to find a T-score?
Sample the
Degrees of
81,
freedom.
80.
Yes, the degrees of freedom. My degrees of freedom is 80. All right. Sorry. I actually went to Scotland like 4 years ago, and I visited a place called Loch Lomond. And I made the mistake of saying, I'm going to go to see Loch Lomond. And he's like, no, it's Loch Lomond. I'm like, holy shit, I'm sorry. Anyway, sorry. So be careful when you go. So this is what I know. It's going to help me figure out what this T-score is. So when you look up 0.01, one tail and you stop at 80, what do you see? What do you get for the t-score?
2.374.
Maybe. I don't know. I don't even have mine up here yet. So is that what you guys got? 2.374?
Yeah.
I don't concur. Maybe. No, I do concur. I concur. If I could just look straight. 2.374. Yes, I like it. Where'd you guys go? There you are. So so what do I put down here? Does this look good?
Yes.
That looks horrible. What's this? This is 0, right? Isn't that 0? So this better be freaking negative. Yes, yes, you guys with me? Be very careful. If it's below the mean, it's negative. So one thing I don't know if you guys have picked up, t-scores are basically z-scores. They're the same thing. T-scores are just z-scores that are bigger to cover my ass for not knowing something. In this case, I don't know the real standard deviation. But they're still fundamentally the same thing. So this is below the mean, it's got to be negative. So if t star is what, then we'll what? How do I get in here? Anybody?
If T star is less than negative 2.374, then we can reject the ha and support the ho.
Careful, no.
So reject the ho and support the ha.
There you go. We never support the ho. You either reject the ho or you fail to reject the ho. You either support the ha or you fail to support the ha. It is very similar to finding somebody guilty versus not guilty. You never find them innocent. Do you guys kind of understand? This is very much like a court case where we have to find enough evidence to show us one thing or another. Okay. All right. So now we know what will be enough evidence. So then we go see, did we get enough evidence? So what do we got from our sample here? What do we got here? We got X bar 880 34. We got S is whatever 106.25. We have N is 81. Now here's where people get freaked out at me. So of course I got to change the standard deviation. Does anybody think I've gone crazy? I could any minute. I could go crazy any minute, or I could start crazy. I could be already crazy. So of course, this standard deviation is good for individuals. I need to make the one that's good for groups of 81. I don't care if it's an S or a sigma. I don't care. You still got to do it. So I get 11.806. All right, let me stop for a minute. You guys doing okay out there? I know this gets very bogged down in a lot of details, but you don't want to ever forget the main idea. There are 5 steps, but all that really, really, really matters is where does the evidence start? Did I make it in, right? So now we got to figure out what our T star is. It's going to be, as always, our data minus the supposed middle, 906, divided by our new spread, 11.806. What does that look like, Jeff? Looks like 2.17. What is that? Negative? That's a major guess. Let me see how far off I am.
That's what I got.
Really? Sorry, I shouldn't sound so surprised. It really is. I mean, I'm sorry. I mean, of course it is. That's what I said, right? I mean, all right, sorry. You too could be close to the real answer in your head sometimes. Anyway, sorry. I'm never going to ask you. All right, let me see if you guys are cool with this. First thing is, you're completely cool with this. I'm never going to ask you to find a p-value for a t-score, ever. The reason behind that, let's see if you guys are understanding. Which one gives more detail? The t-score chart or the z-score chart?
Z-score chart.
Z does, totally. To give the same amount of detail for every degree of freedom on the t-score chart, I would have a chart as big as the z-score chart just for that one row to give as much information. I have no idea if you guys are with me or not, but the bottom line is the t-score chart does not give enough detail to ever be able to find the p-value. You could do it using technology, and I don't give a shit. So anyway, I'm never going to ask you to find the p-value. In an article, you'll see a p-value for a t-test because they use technology. Of course they do. That's good for them. You can too once you're out of my class. Yay! Can we tell the answer though? Yeah, of course we can. What's the answer? Did we make it far enough away?
No.
Hell no. We're like right there. So we're still in the region that would be acceptable for the HO, right? So did we make it? Did we find evidence? Did we make it? No. Did we succeed? No, we fail. We fail to reject the hoe. Fail to support the ha. Fail to read Jeff's writing. There we go. Let me make that. There we go. That's the word writing. All right. Sorry. Ignore the last one. Everybody with me? Does that make sense? You either succeed, so then you do these things, or you don't succeed, so you fail to do these things. So how do I write the conclusion? It's going to be one of these two wordings. Which one was our claim from the beginning?
The huh?
Huh? Oh yeah, sorry. That's correct. The ha was the claim. So therefore, I'm going to word it like this. I mean, do you guys understand what I'm saying? It's never, do I say reject or what? I don't know. No, there's no ambiguity to it. The claim was the ha, so I'm going to use this language. We have not found sufficient evidence. That's how I blow up the word fail. We have failed. So we have not found. All right, Jeff, turn this thing around so you maybe have a chance to write semi-well. Sufficient evidence to support the claim. Come on, you can do it. That the mean credit card debt. Oh my gosh. Card debt. Don't you guys just wish you had a teacher that could write? Wouldn't that be amazing? Credit card debt has decreased from 906. That's all I'm going to say. Has decreased from $906. So we cannot say that the credit card debt has gone down. For everybody. Has the credit card debt gone down for this group of students compared to the overall average? Yes, because theirs is 880. But can we say that means that the credit card debt has gone down for all students? No, it wasn't strong enough evidence for that. Woo! All right. You guys tired and bored? I'm sorry. I agree. That's enough for today. What do you think? That's pretty good. We did pretty good. We still have to talk about type 1 and type 2 errors. So if you get, I think it's in section 9.2, where they talk about the types of errors. So we still need to talk about that. But if I were you, I might just skip to 9.5 and try to do some complete hypothesis test. Another thing we haven't talked about yet is hypothesis tests for percentages. Just like we had confidence intervals of percentages, we have hypothesis tests of percentages. So obviously you're not going to be able to do those quite yet. Is everybody with me still? So you can do section 9.1. You can try section 9.2. You can read about the types of errors and see if it makes sense. You could try to do some of 9.5. Well, you can try it all. Shit, you can read about it and see if you understand it. Okay, otherwise that's enough. Let me know if you need to hang out. If you don't, you are free to go.
Thank you.
Anytime.
Thank you.
Guys.
Thank you. Bye-bye.
Bye, everybody. Your brain hurts, I understand. I have that effect on people. All right, guys. I don't see anybody with questions. I'm going to head out. Bye.